All right, we have come to the biggest part of lesson 3.1, which is how to find an absolute maximum and an absolute minimum given a function. Let's do this. So the instructions say find the absolute maximum and minimum of the function on the given interval. The function is x cubed minus 3x. We've got the interval being between -3, including -3, and going to 1, including 1. Okay, so that extreme value theorem we talked about earlier guarantees, since it's a continuous function on a closed interval, we're going to have a high and a low point. You don't actually have to state that. However, if you're in a challenging calculus course, either AB or BC calculus in high school, or a challenging professor wants you to justify your answers, you should always start out these absolute max or min problems with the following statement. You ready? All right, word for word, you should use this. The absolute maximum will occur at either the endpoints or where the derivative is equal to 0. That's it. Now, in this case, I don't include where the derivative is undefined. Now, we could do it for the minimum as well. The absolute minimum will occur either at the endpoints, -3 and 1 in this case, or where the derivative is equal to 0 or does not exist. And then you go and you show your math. Start out by telling the professor or teacher what it is you're going to do. And by saying that first, you're also giving yourself the script. So again, this is going to happen either at the endpoints or where the derivative is 0, the critical numbers. So I'm going to set f prime of x equal to 0. So we'll find f prime of x, that's 3x squared minus 3. And we're going to set it equal to 0. What you're searching here for are your candidates for the possible very highest y value and very lowest y value. So I'm going to solve this out. I'm going to, well, you can do a number of ways here. I'm just going to set it equal to 0 like we did. So we'll get 3x squared is equal to 3, adding 3 to both sides. Divide by 3 on both sides. X squared is equal to 1. Nice. Now remember, when you take a square root of both sides, it's plus or minus. Right? You got plus or minus 1 there. So that's -1 or 1. That's because -1 squared also gives you 1. So these are your critical numbers. All right, remember those? That's where your derivative is equal to 0 or is undefined. Now there's no place where the derivative could be undefined here. You don't have a place where we could have a 0 in the denominator. So we're cool. These are your only critical numbers. Now, what I want to list now are my candidates. So all you have to do, once you've figured out your critical numbers, list out your candidates. So the candidates for the absolute max and min would be x equals, in numerical order, -3, -1, and 1. Because one of your critical numbers ended up also being the endpoint. So all you now need to do is basically run an election. Check the y values of these x values. They're the only places where we could have a high or a low point, because this point is where our derivative is 0. That's where we could have a hill or a valley. That's one place where we could have a high point or a low point. The other places are at the endpoints. That's it. If you don't believe me, check out the first video we went over in this lesson to see why those are the only places we have to check. So all I now need to do is find f of -3, f of -1, and f of 1. The highest value, the highest y value of these is our absolute maximum. The lowest is our absolute minimum. So f of -3, I plug it in. -3 cubed is -27. -3 times a -3 is going to be a plus 9. Again, all I'm doing is plugging -3 into this. -27 plus 9 is equal to -18. So that's the point -3, -18. Okay, that's our first candidate. Are there other y values higher or lower than this? That's our question. Now I'm going to plug in -1. -1 cubed is -1 minus 3 times a -1. Well, minus a -3 is a positive 3. So that's equal to 2. So that point represented right there is the point -1, 2. All right, another candidate. f of 1. Well, you plug 1 into this and we'll get 1 cubed, which is 1, minus 3 times 1, or just minus 3. That's -2. So here's our point, 1, -2. So without looking at the graph, what's the highest y value? 2. So that's our absolute maximum. And this, being the lowest y value, this is our absolute minimum. So if you needed to be more formal, you'd say, therefore, the absolute minimum is -18. And it occurs at x equals -3. So the minimum value is the y value. The absolute maximum is 2. And it occurs at x equals -1. All right, that's just me being super formal. Let's take a look at the graph just to confirm our diagnosis here. Well, sure enough, we were going from -1, right, which is, let's see, so -1 is roughly right here, right? So -1 is where we had our Yeah, as if I could count. -1 is right here. So that's going to be our maximum, right? And we found that before. And so if we look at our interval again, actually, no, my bad. We went from -3 to 1. It'd be good if I remember these things. So -3 is way down here at -18. Okay, there we go. And then we had that as a point to check. That clearly is the lowest value. We were going out to 1, which is not the lowest value, but it's at a relative minimum. And then right here at x equals -1, that was a relative maximum, which is our highest value, and therefore our absolute maximum. That's it. Not so bad, right? Not so bad at all. All right, let's do one more. So this says, find the absolute maximum and the minimum of the function on the given interval. Okay, again, our goal is to do this without a graph, but I'll show you a graph at the end of this to make sure we're good. So we're now going to go on the interval from -1 to 3. Great, so those are my endpoints. So right away, in terms of my candidates, I know I have -1 and 3 and maybe some other numbers in between. That's what we're going to search for, those other candidates. So again, you make the statement the absolute maximum and minimum will occur either at the endpoints, x equals -1, x equals 3, or where the derivative equals 0 or is non-existent. Let's find out where that is. So we take a derivative. F prime of x is equal to 4 minus, this is going to be 6 times 2/3, power rule, of course, x to the -1/3, which is equal to 4 minus, and this actually ends up being 4, right? 6 times 2 over 3, or 6 and 3 gives you 2, 4x to the -1/3. All right, before you set this equal to 0, I think a really important way to go about this is rewriting it so that the negative exponent is gone. All right, let's set this equal to 0. Also notice that this is not defined at x equals 0. So we're going to add a candidate of 0. That's one of my critical numbers. So I'll say f prime dne at, this is shorthand notation that would not be accepted in the AB or BC exam. You have to write it out. Does not exist at x equals 0. Right? We've got a number over 0 there. But let's solve and see if we can get it equal to 0. So I've got 4 equals to 4 over x to the 1/3. Nice. I'm going to multiply both sides by x to the 1/3. That gives me 4x to the 1/3 equals 4. Divide both sides by 4. Essentially, you've got the cube root of x equals 1. You can do that mentally, or you could raise both sides to the 3rd power. That would give you x to the 1/3. Sorry, x to the 1/3 to the 3rd, and 1 cubed. So x ends up equaling 1 when everything clears. So we have two critical numbers, though. X equals 0 and x equals 1, because the derivative could equal 0 at 1, and at 0 is where it's not determined, right? It's non-existent, I would say, actually. It's non-existent. Okay, so now from here, we now need to test our candidates against all the other y values of each other. So I do f of -1, f of 0, f of 1, and f of 3. Let's do it out. So let's plug it in to our function. F of -1, if we plug it in, is -4 minus 6 times -1. I'm going to write this out to the 2/3. -1 to the 2/3, it's the cube root of -1, -1. Squared is +1. So this ends up being -4 minus 6. It's -10. So that's the point -1, -10. All right, we've got a contender. Plug in 0. 0 minus, that ends up being 0, so it's just 0. It's easy math. So 0, 0. We've got another contender. That was a critical number where the derivative did not exist. F of 1. Well, if you plug in 1, you get 4 minus 6, which is equal to, no arrow there, -10. Sorry, -2. And so that point is going to be the point 1, -2. That can't be a minimum, and it can't be a maximum, because it's less than 0, but also greater than -10. Now we plug in 3, and 3 I had to plug into my calculator. You would have a calculator in a problem like this. That equals 4 times 3 is 12, minus 6 times 3 to the 2/3. Yeah, that's kind of hard to do mentally. So in the calculator I get -0.481 approximately. So that point is the point 3, -0.481. Okay, so a very close second to the maximum, but the maximum value is 0, 0. So the maximum value is 0. And the minimum value is -10. So if you had to make a formal statement, you'd say the absolute minimum is -10. It occurs at x equals -1. The absolute maximum is 0. and that occurs at x equals 0. So let's take a look at the interval from -1 to 3 on this graph. Oh, it's a funky looking graph indeed. Here we had the absolute maximum, and sure enough, that is the highest point. Remember, we're stopping here on our interval and starting there. So -1, -10 was clearly the lowest value overall. That's the absolute minimum. The maximum was right here where the derivative did not exist. Make sure to look out for any of those points where the derivative doesn't exist. Some people just set that last problem equal to 0, and then they miss out this critical number, which ended up being one of our answers. Very cool looking graph. All right, peeps, I'll leave it at that. Abs, max, and mins, they happen at endpoints or critical numbers. Peace.